Hello, good morning everybody. Today we will learn about set theory, which is chapter 1 in class 11, volume 1, ISC. So without wasting any more time, let's learn about set. At first, we'll see the definition. What is set? A set is nothing but collection of some objects in a well-defined way. That's mean suppose we are giving some examples. Let's say collection of even natural numbers less than 10. Okay, that's mean we are talking about uh, 2, 4, 6 and 8. Okay, so this collection can be expressed like this. Always remember, to express a set there is two types of notation. We will talk about it later. First understand the definition. See here, 2 point is very important in the definition. Number 1 is collection and number 2 is well defined way. Now what is the meaning of these two? See, I think you have understood the concept of collection. Here is a collection of some natural numbers or obviously some objects, which is the collection. Number 2 is well defined. Now what do you mean by well defined? See, if I say that if I say that collection of all good books in mathematics. So here is the problem is that you cannot list of any particular books because here is the problem. Good books. What do you mean by good? A book may be good for you but not good for me. So that's why you cannot list up any certain elements. If you list up the objects, your list will be different from my list. So in that case, this collection is not well defined. Is not well defined. So this collection is not a set. Okay, but this is a set. This is a set. So that is the basic concept of the definition of set. Now we will go to the concept of representation of set. There are two type of representation, type 1 and type 2. Type 1 is called the roster form or tabular form. Okay, and number 2 is set builder form. The roster form is very natural to understand. If I give the example, of this one, first example, and this notation was actually nothing but the roster form or tabular form. Okay, if I say that uh, if I use the previous example, in this case the set will be, you can name it anything, A, B, C, whatever you wish. So let's A equal to that set 2, 4, 6, 8. And my question was collection of all even numbers, even natural numbers, collection of all even natural number less than 10. Okay. So that is my set. But in set builder form, the same set will be expressed as, see, the concept is, uh, give a brace notation first. This second bracket, some of you call it second bracket, but actual name of it is brace notation. Okay, brace notation. So the brace notation, inside the brace notation, first write x. What is x, or why we will write it as x? See, think of the elements of these sets. Okay, or your question, think of the objects what I want to write. I want to write even, natural number, and less than 10. Okay, so these 3 points you should think of in your mind. And first write x, and after that write down the property of x. That means you are actually saying that A is nothing but the collection of all such x for which x is even, comma, x is natural number, and h is less than 10. Okay, so these three property of x you should note down after this slash, or you can give some semicolon in this place, okay. So that is the set builder form. Now see, the same set has been expressed in two different way. Okay, the first one is in roster form, the second is in the set builder form. Okay, so you can think of more examples. Okay, in the next slide we will uh, see different kind of sets. Number one is empty set. What is empty set? Empty set is the set containing nothing. You can say it as void set or empty set or null set. Okay, and the denotation would be like this: phi. Phi means empty set. Okay, and some examples of it is like, if you say that collection of all natural numbers less than 1. Why this set is phi or null set? Because you see, the natural number is start from 1. What is the set of natural number? The set of natural number is 1, 2, 3, dot, 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 to infinity. Okay, so this is my natural number collection. But if I want to express some natural number which is less than 1, that means the number which is left side of 1, it is almost impossible, because the first natural number is 1. Okay, so there is no any natural number which is less than 1. That means this set, this collection contains nothing. So that is a very good example of empty set. Okay, number 2 is singleton set. Number 2 is singleton set. Singleton set means the set containing a single element. For example, if a set is like this, 1, okay, suppose b is equal to minus half, okay, so the set which contains only one element is called the singleton set. Okay, number 3 is finite set. What is finite set? Finite set means the set which contains a limited number of elements. The set containing limited number of elements. Okay, for example, if A is a set which is like 1, 2, 3, 4, 50, so there is 50 elements in there. But if I express a set like this, all natural numbers, suppose 1, 2, 3, it is not ending anywhere. Okay, so that is not a finite set, that is a finite set. This type of set is called infinite set. We will go to it later. Okay, so number 4 is infinite set. So there are actually two type of infinite set. uh, See, I will teach you through examples. That is very easy to understand. Suppose A, let A is a set like that, 1, 2, 3, running, okay, to infinity. So that is not ending. This is also infinite set, and this is also an infinite set. Uh, 1 half, 1 by 3, 1 by 4, 1 by 100, running. So that is also an infinite set, obviously. But and suppose the uh, set x, where x is equal to p by q, where p, q both are integer and q not equal to 0. Anybody, do you know what is the type of set C is? Actually, C is rational number set, which is represented by capital Q. Okay, but there are some special sets whose name are there. I will talk about it later. So this is a collection of all rational number. Okay, so rational number means any fraction, 1 half, and between 1 and half. See, in this example, there was 1 half, 1 by 3, but between 1 and half, there are many fraction like 0 0.9, 0 0.8, 0 0.7, 0.77. So these points are not in this set, but in here all such type of fractions are there in C. Okay, so here see, A is also infinite set, C is also infinite set, but what is the basic difference between A and C? A A can be counted but infinite. Okay, C also can be counted. How? I will teach you later. But if I say the set of all real numbers, means real number means what? Collection of all rational numbers as well as all irrational numbers. Irrational number means root 2, root 3, okay, e, I, etc. These are irrational numbers. These cannot be irrational. These are irrationals. Okay. So if I include these type of elements with C, that becomes my real number. Okay, and the set of all real numbers is expressed by capital R. So that is my real number. So this set is also infinite but cannot be counted. Okay, this set cannot be counted. Very, very important. So this is countably infinite, but this is not uncountable infinite. Okay, so there is two types of infinite sets are there. Okay, okay. For today, this is the end of the demo class today. Okay, my name is Professor Jagannath, and my contact is 7872336063. If you like my class, we can teach you further for the set theory and all other chapters as well. For any personal, this is my WhatsApp number. Thank you.